Hello everyone, my name is Kumar and I'm a third year student of engineering physics at IIT Roorkee. Today I'm going to present about the topic time division multiplexing. Firstly, we understand what is multiplexing. Multiplexing is a key technique in telecommunication that allows multiple signal or data to be transmitted simultaneously over a single communication channel or a medium. By efficiently sharing a common resource like a cable or a frequency band or an optical fiber, it reduces the infrastructure cost and improve the communication efficiency. Multiplexing works by dividing the available bandwidth of a communication channel into smaller segments, either in terms of time frequency or other properties, and assigning these segments to different signals or users. This ensures that several users can share the same medium without interference or data loss, making it a very crucial technique in modern day telecommunication systems. To understand this, we can create an analogy. Imagine you have a highway where only one vehicle at a time can go to reach their destination. The highway would be very underutilized and complicated system. To ease the system, we have created a multiplexer, which we can widen the highway and allow many multiple vehicles according to their time slot to reach their destination. Now we understand the types of multiplexing. We have three types of multiplexing. First, frequency division multiplexing. Second, wavelength division multiplexing. Third, time division multiplexing. Firstly, we understand about the frequency division multiplexing. It is a technique that splits the communication medium bandwidth into multiple non-overlapping frequency band carrying a separate signal. This allows multiple signals to transmit simultaneously over a single channel while minimizing the interference. Each signal is assigned a different frequency range or subcarrier. There is enough frequency separation called adjacent signals to prevent interference. Signals are transmitted simultaneously. Each user has a continuous transmission within their assigned frequency band. For example, radio and TV broadcasting. Different stations use different frequency for their broadcasting, and receiver can tune to any frequency for particular station broadcast. Second is analog telephone system. Multiple telephone conservation are transmitted over a single cable by allocating different frequency ranges to each call. Second type of multiplexing is wavelength division multiplexing. Wavelength division multiplexing, it is a technology which multiplexes a number of optical carrier signals onto a single optical fiber by using different wavelengths colors of laser light. This enables us for a bidirectional communication over a single strand of fiber, also called wavelength division duplexing, as well as multiplication of capacity. Optical signal. A wavelength division multiplexing is used for optical fibers, where different light wavelengths are used for carrying separate data streams. Dense wavelength division multiplexing. It is a more advanced form of wavelength division multiplexing, which uses closer spacing between wavelengths, allowing more signal to be transmitted simultaneously. Wavelength division multiplexing significantly increases the capacity of a single optical fiber, allowing for high-speed communication networks. For example, fiber optic communication. Wavelength division multiplexing is used in long-distance fiber optic communication system where multiple data streams, just as internet, voice call, video call, are combined and transmitted over a single fiber using different wavelengths of the light. Third, and the most important division multiplexing is time division multiplexing. It involves sharing a common communication channel by dividing it into multiple time slots and which can transmit their data. Since the switching occurred very rapidly, it appears as all the information are transferred simultaneously. Each user or signal is assigned a different time slot. Signals are transmitted one after the another in sequence, which the user have exclusive access to the channel during time slot. The most important part of the time division multiplexing is synchronization. Both receiver and sender has to be synchronized in such a way that they need to understand which time slot corresponds to which signal or a user. For example, digital telephony. Time division multiplexing is used in digital telephony, where multiple phone calls can share the same communication channel by using different time slots. GSM, Global System for Mobile Communication. GSM uses time division multiplexing to allow multiple mobile users to same frequency by allocating different time slots to each user. Here are some key differences between frequency, wavelength, and time division multiplexing. You can see that the medium for frequency, wavelength, and time are almost same, but the signal type for frequency is analog or digital, but in wavelength only optical signals are transferred, and time division only digital signals are transferred. And in such a way you can see simultaneous transmission is only allowed in frequency and wavelength, but not in time. Separation mechanism, they have different separation mechanism also. There are two types of time division multiplexing. First is synchronous time division multiplexing. It is a time sharing technique where the total available time is divided into fixed equal time slot for pre-assigned to users. Each user gets a time slot whether they have to send data or not. This type of time division multiplexing requires very strong connection between transmitter and receiver to ensure that receiver should know which signal is corresponds to which sender. Second, asynchronous time division multiplexing. It is also called statistical time division multiplexing. It is the more improved and efficient version of time division multiplexing. It allowed and dynamically to users according to their need of transmission. The time slots are not fixed and assigned when the data has to be sent, making it to be more efficient towards the bandwidth usage. Now we're gonna implement time division multiplexing using MATLAB software. Here we take two signals. First is sinusoidal signal, second is triangular signal. First we take sine function in MATLAB. Here we describe the time range, the function sine and plot. Here you can see the output of the sine function. Secondly, we have used triangular function in MATLAB. Triangular function is a triangular pulse shape generation of length L, and for detailed explanation you can check method documentation for more details. Here you can see the output of the triangular wave pulse generated by the length t, which is same as the sine function. Now, for continuous signal, we use the function plot, but for discrete time signals, we use the function stem. Here you can see that in code we have used stem function, and we have plotted both the signals, sine function and triangular function. Now, let's do multiplexing. The method of multiplexing is very simple. We have to take one function, and that very next instance we have to take second function and repeatedly perform till our time value is finished. You can simply see the code for multiplexing. Here we have matrix y1, and here we include two row matrices. Such first is x1, which is our sine function. Second is y1, which is our triangular wave pulse of same length as sine function. Here is the output of our time division multiplexing. Here you can see that after every instance there is another function has value taken in the output. Now a question arises that it is possible to reconstruct the original signals after time division multiplexing. The answer is yes, but how? The answer is demultiplexing. Demultiplexing is nothing but we have to reverse the multiplexing. Here you can see in the code we have generated row matrices out of our time division multiplexing matrix to get two rows. First row is our recovered sine signal, which is our first signal, and second signal is recovered triangular signal that we have used. Here you can clearly see the output of a demultiplexing of our signal. First is recovered sine signal and second is our recovered triangular signal. Thank you for your time.